For a computer of this scale, a professional would quote 11 weeks or so of just straight design work. And so something that takes a professional who's well paid 11 weeks to do is clearly a complicated task.
But at the end of the day, like, I don't know who else could place and route an entire baseboard and an entire SOM module, mostly from scratch, have it quick turn prototyped and get it back, and it runs Linux the first day without any hiccups.
And what I like to think about is, now that we've given them a better tool, how far can they take it? How do we enable the great creative folk who are doing this work today to do more than they thought was possible?
Holy crap, it's working.
That's wild. This is so wild.
The goal was to have a computer that can run Linux, that you can go on Chromium and browse websites, watch videos. Like, you do any of those sort of normal things you might do with a phone or a tablet as a single board computer.
It's useful to pick a very concrete goal that is a stretch goal, something that is difficult and you can't immediately do, but not too far out, something you could picture doing in 6 to 12 months. We picked this goal because it would accomplish multiple things. So the number one thing it did, and the reason we focused on it for this year, is that it pushed the whole team to make Quilter better, right? It pushed us to do things like generating polygon pours, doing length matching, and other important elements of design. You would find this kind of computer in like your car infotainment system, which is what this chip is built for. And so you could imagine real professionals building this into their, say, car design. And so the fact that we could do it, and we could do it 10 times faster than is traditional, is a breakthrough for us, but also a breakthrough for the industry.
I think it's important when you realize that every piece of copper is hand-drawn by a human printed circuit board, that you realize that it's hard to make things, but the reality is it can go a lot faster. But it is a hard problem.
Some people who know what this is and know what NXP chips are may recognize that board outline and shape is pretty much the i.MX 8 mini evaluation kits. Rather than get mired in the front-end electrical engineering of a single board computer, we don't need to reinvent that wheel. There's a lot of existing good reference designs out there. You can get the original schematics for it. The goal is, like, obviously not to regurgitate the exact same thing again, but the goal is to use a platform where if it works, and we can easily prove it works because we are running standard software on it. There is no design known to man of moderate or greater complexity where at least one of those components, if not several, somehow during the design process, at the beginning they're available in supply chain, and by the end, some of them are no longer in supply or they've been allocated and you have to find alternatives. So I had to update these footprints, this one, and the push button switches, which you see on this baseboard. I've actually taken them off, and that's another side story. I had to create new footprints in the library because I had to move to completely different parts from different manufacturers for those.
The world is full of people doing very hard and menial tasks. So when you think about automating something that is so repeatable, so scalable, once with the right tooling, that it really could unlock something that's much greater. It could unlock a lot more creativity in things that we make and advancements that we make. Because in a lot of ways, we're held back by the tools that we use.
You typically don't just make one board in one go and hope for the best. You're typically making lots of prototypes, lots of individual test cases, lots of revisions to your board to get that going. If you can automate the design of the board, you can do it very quickly, and you can do it many times in parallel. All of a sudden, you can try lots of different design rules. And so if you can compress each of those cycles from months to days, then you do that for 5 or 6 or 7 cycles. It means you can get to market months, if not a year ahead of time. It's about consistently being faster, consistently being at the edge, consistently factoring in the latest chips and latest technologies. There's at least 10 times as many people who want to make circuit boards as those who actually know how to make them. Probably 10 times as many people who know how to read and write schematics and even have the capability of defining what board they want to make. The way I think about this is that in general, the entire progress of civilization as a whole is measured by abstraction. What Quilter represents is a major leap in abstraction in this arc of electrical engineering, where we are effectively taking away the kind of nitty assembly that you have to write as a software engineer, and we're giving you a compiler. Today is definitely the best time to be alive as an electrical engineer. There's no question about it. The amount of exciting things we can do, the amount of possibilities has been growing and is starting to grow even faster.